My name is PVS the tutor. Welcome to this video. In mathematics, we'll be revising a 2018 GCE paper 1. So we'll only revise from 1 to 10, then we'll be going like that. So with me here, I have a question that says simplify 4 open brackets x plus 2y minus 3x minus 8y close the brackets. So we'll learn on how we can simplify such type of question. So when you've been told to simplify this type of question, step 1, you need to expand. So you need to expand this. So 4 times x, you'll get 4x. Then 4 times positive 2y, you get positive 8y. Then there is negative and here there is positive. So negative times positive, it's negative. There's 1 here outside. 1 times 3x, you get negative 3x. Now negative times negative, you get positive. 1 times 8y, you get 8y. Stage 2, you need to correct the right terms. You need to correct the like terms. So therefore, 4x and negative 3x, they are the same. We're going to correct them. So 4x minus 3x plus 8y plus another 8y. Now, of course, we need to subtract it because there are different signs. Here is positive 4x and negative 3x. So remember, when you subtract it, you get a sign from a bigger number. 4 is bigger than 3, so our answer must have a positive number. So 4 minus 3 is x, it's 1. Then you maintain your variable. So you're going to have x here. Then since these are also same signs, you add and maintain the sign. So you're going to have positive there. 8 plus 8 is 16. Then you maintain your y. Never be tempted to add these as well. Y and y, you say y squared or 2y. No, you only add the coefficient, which is d. So that is our answer. So let's go to question 2 that says evaluate 27 to the power 2 over 3. Now these are indices. So what this means is we need to find a number that we can raise to the power 3 to give us 27. So we need a number. Let's call that number A. We can raise to the power 3 to give us 27. You discover that the only number that we can raise to the power 3 to give you 27 is actually 3 to the power 3, which actually will give you 27. So what we need to write here, it's a 3 to the power 3, like that. Then outside, you put 2, the same 2 over 3. Now, you therefore need to cancel what is the same. You cancel this, you also cancel that because they're the same. What you remain with 3 to the power 2. So you remain with 3 to the power 2. Therefore, when you remain 3 to the power 2, what is 3 to the power 2? It's 3 times 3. So you get 9. As your final answer. So these are rules of indices that you must know. You should also know that any number raised to the power 0 will give you 1. That's what you must know. Any number raised to the power 1 will give you that same number. You must also know that any number raised to a negative number, it will be 1 over that number to the power, the positive of the power now. For example, what I mean by this, for example, if I have 2 to the power negative 2, this is the same as 1 over 2 to the power 2. This means inverse of the other, reciprocal. So let's go to question 3 that says a straight line passing through A 3, 2 and B 5, y has a gradient negative. To find the value of y. Now before I go in further, let me talk a bit about gradient. Gradient see letter M is equal to y2 minus y1 over x2 minus x1. Now these are lines. Imagine there's a line. Imagine there's a line like that. Imagine there's a line, and that line has got two points, A and the B point here. Now this is a coordinate here, and that is a coordinate there. Now we know that all coordinates have got x and y. Okay, even here we have x and y. So we have those coordinates and these coordinates. So we can call these coordinates 1 and these two coordinates 1 as well. This one can equal to it 2 and that one 2. So now I need to find the difference in terms of y. So y2 and y1. Also the difference in terms of x, x1 and x2. So that's exactly what we need to do here. So let's get rid of this. So therefore, let's go. M is gradient. We have been given that gradient is negative in this case. So I'm going to put -2 is equal to y2. Y2 is the same y there, you can see, minus y1 is 2. Sorry. Y1 is 2 over x2 is 5. So x2 is 5 minus x1 is 3. So x1 is 3. So let's go. So this is -2 is equal to y minus 2 over 5 minus 3 is 2. Now I'm gonna cross multiply here. 2 times -2 is -4 to give us y minus 2. Now we need to collect the like terms. -4, this -2 when it crosses the equal sign becomes +2, which is equal to y. Now -4 plus 2 will give you a -2 answer as is equal to y. So y is equal to 2, -2. Let's go to our fourth question that says factorize completely 5x squared minus 5. So we have 5x squared minus 5. So to factorize actually is to get out what is common. So in this case, we're going to factorize, take out what is common. 5 is here and 5 is there. So when you take out 5, when you divide 5 into this, what are we having? 5x squared over 5. You see that 5 and 5 they cancel. What we remain with is x squared. So what we remain with is x squared there, minus 5 into 5 is 1. So that's what we have. Now we can further factorize this using difference of two squares. If you have something like this, you can factorize further. This becomes x minus 1, close the bracket, open bracket, x plus 1, because this is what we call the difference of two squares. It's the same thing when I have this minus 4, because 4 is a square. I'm going to have x minus 2 square root of 4 and x plus 2, so that when I multiply this one, it will lead me back to this one. So actually we do the squares. 1 is a perfect square, 4 is a perfect square, 16 is a perfect square, 9 is also a perfect square. So in short, we are finding the square root of x, which is x, square root of 1, which is 1. Then you repeat the same but with an opposite sign. Now 5, use the set notation to describe the shaded region in the Venn diagram below. A and B have been shaded respectively, but C hasn't been shaded. Now we need to understand that what has not been shaded takes a complement. A complement means things not found in that set. So in this case, we have C. We have C complement. We have C complement because C has not been shaded. Then intersect. What has been shaded takes no complement. A union B. So what they have shaded is only A union B intersect C complement. In short, they are saying